Hello everyone. In this lesson, we'll be discussing about the concept of cyclones and the different types of cyclones, that is tropical cyclones and temperate cyclones. I am Bhumika Saini. I've done my engineering from NIT Jaipur. You can follow me on Unacademy by following this link. Unacademy courses are free of cost, but if you like the course, you can pay an optional fee by following the contribute link on Unacademy. Now, what are cyclones? Cyclones are low pressure meteorological systems where the wind moves towards the center along a curved path. You can see it in this diagram that the winds they are moving towards the center, that is the low pressure, and along a curved path with increasing centripetal acceleration and the Coriolis effect towards the center. So Coriolis force is required for development of cyclone. So these are low pressure meteorological system and they move in anti-clockwise direction in northern hemisphere and clockwise direction in southern hemisphere. Okay, and these are secondary circulations that are produced by thermodynamic changes in the primary circulation that we'll discuss in the next few slides. And these cyclones they transfer heat and moisture across the latitudes and thus they help in maintaining latitudinal heat balance. So there are two types of cyclones, tropical cyclones and temperate cyclones. Tropical cyclones in tropical regions, and they are known by different names also, like cyclones, hurricanes, typhoons, etc. Then temperate cyclones, also known as extratropical cyclones, they are found in the temperate regions. Now let's discuss about tropical cyclones. So the conditions required for origin of tropical cyclones are: first, sea surface temperature should be greater than 27 degrees Celsius. Now that is why these cyclones are limited or the period of origin is limited between April to September, because the sea surface temperature has to be greater than 27 degrees Celsius. Now minimum value of Coriolis force is required because initial torque is provided by Coriolis force. That is why these cyclones are not found in the equatorial regions, that is between 5 degree north to 5 degree south, because there the Coriolis force, like at the equator, Coriolis force is zero, right? And these cyclones they are intensified beyond 8 degree north and south because there is significant Coriolis force there. Now apart from this, a minimum vertical wind sharing is required for tropical cyclones. That's why they can't be formed in subtropical high pressure region, that is 30 to 35 degree latitudes. Why? Because here the descending wind system is there. Okay, the next condition required is upper air anti-cyclogenesis condition should be there, that is needed to maintain low pressure over the ground. So when there is low pressure on the ground, then there is upper air anti-cyclogenesis conditions. Then apart from this, there has to be huge amount of water vapor above sea plus latent heat of condensation, that is needed because it's the latent heat of condensation only that supplies energy to the cyclone, right? Now these cyclones they are pushed by trade winds, right? And as they move over the sea, they are gaining water vapor and latent heat, and they grow in size and become mature, right? And apart from this, intense convection and air currents in the center and converging winds at the periphery, that is also another condition for origin of tropical cyclones, right? So this origin of tropical cyclones can be studied in different stages: initial stage, formative, juvenile, mature, and dissipant stage. Now let's study each in detail. In the initial stage, air motion is becoming circular. Here isobars are ill defined. Now in this particular stage, only the central core is developed. You can see it in this diagram that this one is the initial stage. Here only the central core is developed and the winds has just started converging. Okay, now in the second stage, that is the formative stage, here eye will be developed and activity will begin around the eye, and in this case you can see that isobars are becoming circular. So in the first one isobars were ill defined, but in this case the eye has developed. This one is the core, this is eye, then gradually these isobars are getting developed. Now in the third stage, that is juvenile stage, air convergence, convection, cloud formation, rainfall, they all become conspicuous because in this stage this cloud formation, convection, you can see it in this diagram, the convection is taking place, then cumulonimbus cloud formation is taking place, the winds are descending at the periphery, so gradually it is becoming mature. Okay, and in the fourth stage the series of clouds are fully developed, full development of eye and eye wall, right? Spiraling bands of clouds you will see, hurricane winds or winds of high velocity they have started blowing, and this cyclone system, this whole begins to move over the sea surface. So this is the mature stage, okay, where this whole cyclone is gradually moving over sea. Right now the last stage, in the dissipant stage, when this cyclone falls on land, there is the supply of moisture is cut off, right? And that is why this cyclone gradually dissipates. Okay, but as it falls on the land, it brings about catastrophic weather events like cloud burst and high rainfall up to the range of 100 centimeter within minutes that can occur, right? So these are the 5 stages of origin of cyclone. Now cyclone in this we can also study the vertical structure of cyclone. Like first at the center there is eye, then surrounding it there is eye wall, then there is inner ring, outer ring, and annular zone. Now this eye, that is the core of cyclone. Here with the maximum temperature is there. Now this is a zone of relatively calm condition. Why? Because the air is mechanically subsiding here. You can see it here in this diagram. This is eye, right? And here the air is mechanically subsiding. So this is zone of calm condition. Now the next one, that is eye wall, that is surrounding the eye. This is the zone of maximum activity. Here all the ground convergence of winds and intense convection takes place. Rising air currents you can see in this eye wall. So in this zone you'll see thick cloudiness, thunder, lightning, cumulonimbus clouds, release of latent heat of condensation, torrential downpour. All these conditions you will see in the eye wall. This is eye wall, right? Surrounding the eye there is this eye wall. Okay. The next one in this is inner ring. Now as we are moving away from the eyeball, we'll encounter moderate weather conditions. So the wind velocity here is 60 to 80 km per hour. Rainfall here will be due to cumulus and stratocumulus. Now in eyeball the rainfall was due to cumulonimbus clouds. Okay, and as we are further moving away from the eyeball, that is in the outer ring, further cool and calm weather conditions will be there. There will be sea breezes, velocity gradually decreasing. Now velocity is less than 40 km per hour. In inner ring the velocity was between 60 to 80 km per hour. So as we are moving away from the eyeball, gradually the calm weather conditions are prevailing, right? And here stratocumulus clouds may cause drizzle. So in the inner ring it was rainfall, in the outer ring it is drizzling, and in the eyeball it was thunder and lightning. Okay, now the last zone, that is annular zone, it surrounds the cyclone, and it's the peripheral zone where subsiding cold and dry winds, the cold and dry winds, they are subsiding. This is annular zone in the diagram, right? So this one is eye, then it is eye wall, then inner ring, then outer ring, and the last one is annular zone where these winds are subsiding. Okay. Now the horizontal components of cyclone, they can be classified into 4 regions. You can see it in this diagram. These are the 4 regions: region 1, region 2, region 3, and region 4. Now in region 1, that is the layer, the upper layer, that is at an altitude of 10 to 12 kilometer. Here mainly the winds are flowing outwards. You can see it here. This one is the region 1. The winds are flowing outwards, right? So this is outflow layer. Then region 2, this is upper tropospheric layer, that is at 6 to 10 kilometer height. Here you will see thick cloudiness, spiraling bands of cloud, diameter in the range of 100 to 150 kilometers. So this zone, right? Here you can see the clouds in the diagram, and this is highly energized zone. Okay. Then the third zone, that is middle tropospheric layer, huge amount of latent heat is released. This is also known as convective layer. Okay, this one is also highly energized zone, just below this upper tropospheric layer. This is the third zone, right? Or third region. Here you can see these clouds, right? Then the last, that is lower tropospheric layer. Here air convergence is taking place, high velocity winds are there, right? And this mass of air and water vapor, they are lifting, right, in this particular zone, and the diameter here is maximum 400 to 500 kilometers. You can see this one is the region 4, right? So here the diameter is maximum. Okay, the convection is taking place, air convergence is taking place, right? So this is about tropical cyclones. Now the devastating mechanism of tropical cyclones, they can lead to sea swell that causes flood. They can lead to coastal upsurges. Here water is rising along the coast and again leading to flooding. Then it can lead to cloud burst condition, heavy downpour, hurricane winds, that is wind velocity in the range of 120 km per hour. Then it also leads to lightning due to cumulonimbus clouds, and that is mainly in the eye wall region. So this is all about tropical cyclone. We have studied about the horizontal components, vertical components, the different phases in which the tropical cyclones occur, right? The initial, formative, juvenile, mature, and incipient stage, right? And the conditions for the origin of tropical cyclone. Okay, thank you.